And I felt good about it. I'm like, sweet, this is going to come in useful later. Now, I do believe I mentioned that we can use some of these technologies for net neutrality, and this is the point in the talk where things go strange. I was unaware this was such a hot-button subject when I talked about making tools to detect network neutrality issues. My net neutrality stuff from last year was great, worked wonderfully. It required you to send so many packets that the link would break. It turns out that's very difficult code to release, though I had enough bandwidth to do it. One thing about net neutrality we need to stop referring to as net neutrality. You do not beg for the status quo, thank you very much. I refer to provider hostility. And here's a very good definition of provider hostility. If you're sniffing my traffic, hostile. Altering my traffic, really hostile. Censoring, basically, think of it this way. Would the US military bomb the crap out of you for doing it? You might be hostile. I'm just saying. This stuff is happening. Check this crap out. The goal is to identify the applications being used on the network, but some of these devices can go much further. Pick out the HTTP traffic, drill further to catch the traffic going to and from Gmail, and can reassemble emails as they're typed out by the user. What kind of creepy shit is this? Get out of my traffic. Everyone who knows anyone who's dealing with stuff that making routers knows, my God, the carriers want evil stuff. That's what they're buying. That's what they're looking for. There are repeated news articles about ISPs replacing ads, and companies setting themselves, in fact, up as ad replacers. Can we do something to monitor the spread of this? Can we defend? Yeah, you want to talk about weird? Me. I'm getting into the business of saving online advertising. What the shit? So I call this the Times Square effect. If you ever see Times Square in New York City, you are not actually seeing Times Square. All the advertisements have been replaced. Because there is no contractual obligation not to replace the ads and there's money to be made. Well, when you go to Google, your carrier is under no contractual obligation to actually show you the packets that Google was providing. Someone finally realized that man-in-the-middle attacks can be really freaking profitable. And let me tell you, the providers, they like profit. So the deal is with ads, we bitch and moan. Most users don't mind. They don't know. They go to a page, there's an ad, maybe they click. They don't know if it was the ad from the page, the ad from somewhere else, and the providers know it. And let me tell you, it's a hell of a lot cheaper to pay the provider to put some stuff on the page. In fact, can you imagine if you could pay $1,000 and be the top link on Google? Because let me tell you, Google won't take your money. You want to be the top link on Google, you got to do crazy search optimization. Yeah, I got search optimization with a 7-figure check. That's the kind of search optimization that some people would like. And that's the kind of things that people are really looking into because, people like 7-figure checks. So, what do we do to detect provider hostility? What does it mean? Well, downloading data from 2 different sites at 2 different speeds, that doesn't tell us crap. The internet's a big place. There could be an issue anywhere. What we need is, given identical network paths for 2 websites, is the last mile provider hostile to content from one site versus another? Meaning, we've got to take the entire internet and we've got to make it go under the same network path. And then we can start drawing conclusions based on differences in speed and differences in content. Well, let's look at what kind of tricks we can do. Sometimes, when we're on a network, we have a transparent proxy. These things take all traffic outbound, no matter what the IP address is, and if it's port 80, they will move it to a given device, and you'll just talk to that web cache. This is fantastic, because with Flash, we can say, hey, I'm going to get slash from host Google, or host Yahoo, or host MySpace, and it will always go to the same server in the last mile. And if Google goes at one speed, and Yahoo goes at one speed, and MySpace goes at one speed, or if the content is changed for one and not the other, well, we now know that this ISP favors this company and not this company. Perfect. Now, there's only one problem with this. Transparent proxies suck. They're really unstable. They're so unstable that a lot of them got deployed and then pulled back because they just didn't work. Now, that doesn't mean, however, that these sensors can't get in the way. they can go ahead and they can allow you to do all your normal traffic, no proxy in the way, but if they see you trying to go to Google, they see you trying to go to MySpace, then they go ahead and mess with you. Well, we can go ahead and using Flash, we can go to port 80 and say, yeah, test IP, I'm trying to download stuff from Google. And the sensor says, wow, Google's got a new IP. I better go mess with it. And then you bust them that way. There is a problem. Problem is detectability. Now, in every major networking company, I assume there's a protocol guy just as ornery as I am. And he's sitting there like, I'm totally going to detect Dan doing that. Oh yeah, I know all of Dan's IPs. I see him do all of his scans. I can see his weird-ass packet tricks from a mile away, no problem. So I'm like, all right, I wonder, could I make a net neutrality verifier so good even I couldn't detect it? I figured either way I would win. And indeed I did. Well, let's look at the problem for a second. Internet's big, we're little. There are, in fact, repeated accusations that, for some strange reason, the speed test sites that measure how fast your internet connection is, wow, they're really fast. Only when you're connecting to the speed testing sites. These guys get all the bandwidth, everyone else not so much. A site that is detectable will get messed with. We want to be everyone and anyone as far as the ISP knows. We want to be able to spoof anyone. We don't want the real sites to mess with us, and we really don't want the ISP knowing what we're up to. Well, in order to do this, we would have to spoof traffic. And anyone who knows about spoofing traffic on the internet knows you can have any IP address you want, but to spoof on TCP, you need sequence numbers. And let me tell you, I don't care how crazy the bugs are in Flash. You're not getting a TCP sequence number out of Flash. You aren't getting TCP sequence numbers over JavaScript. I mean, that's just never going to be possible, and oh, hell no. I swear to God, this just makes me happy. It fires a JavaScript event every time you get a packet. It gets the payload of the packet. You can do whatever you want with it. This should not be. All right, now we can do some evil things. Because now, yeah, you can actually go to a website and it can get sequence numbers. I am building a tool. It is called Inspector Packet. Normally, Mallory, our quote-unquote attacker, does not know the sequence number the client will accept. Normally, Mallory has to compete with the real server for sending of the data. Well, let's look at what we have. We have a sniffer that will leak all the sequence numbers that we could possibly have to Mallory, to quote-unquote the attacker. Now, what the attacker do? Attacker has the sequence numbers. Attacker can spoof data. Okay. Attacker spoofs some data. Client gets it. Client's like, great, I got data. Hey, real server, I got data. Isn't that great? Yeah, isn't the real server going to be really unhappy with that? Not if we tell the real server to go away. There's this wonderful thing called a TCP reset. With enough knowledge about a socket, you can forcibly close a socket with a TCP reset packet. It requires the source and destination IP, it requires the source and destination port, it requires the source and destination sequence and acknowledgement number. These are all things our sniffer has so helpfully provided. The reset can be delivered to either side, either the client or the server. So if the attacker sends the real server a reset, it will ignore all traffic from the client. Ah, but wait! It's not supposed to do that. By the RFC, if you receive an acknowledgement on a session that doesn't exist, clearly something is wrong with the client, and you should be helpful. And you should tell the client, go away, reset, I tell you something is wrong. Ah, I love internet security. We have firewalls. Firewalls are like, if you receive an acknowledgement and there is no session, dear God, it must be a hacker, ignore. Close your eyes. Say nothing. Do not interfere. Thank you so much, firewall vendors. I love you guys. So how does this look? The client is going to send some traffic to the server. Server is going to totally ignore it. The attacker is going to send traffic to the client. And as far as the ISP knows, that looks like the server, because it's got the right sequence numbers, it's got the right IP addresses, and the client is accepting it and acknowledging it. Of course it's acknowledging it. It's in on the game. As far as the provider in the middle is concerned, the client is talking directly to the server. Therefore, the client and the quote-unquote attacker can collaborate to make the eavesdropper hear whatever the heck they want. Any changes in content, any changes in behavior are not because of some random stuff happening on the internet. No, that's the last mile being a little evil. And that is the game. So, conclusions after this fun adventure. DNS rebinding sucks. Totally screwing with your firewalls. If I could say one thing, please, if you have a home router, change the default passwords. In fact, change default passwords if you have them anywhere. They're all hosed. We got to start worrying about ISPs being evil, because it turns out it's really profitable and they like profit. There are mechanisms for detecting evilness, and they will be deployed shortly. To anyone who works for an ISP, consider this fair warning. I am done and open for questions. All right, anyone got a question for me? All right, I'm going to stand still. Go ahead. Oh, here we are. Cool. We need some mic help here.
Hello?
Yeah.
This two-way bidirectional channel will only hold while the browser is open on the evil page, or will it stand, like, do you demonize it or have something?
Great question. So you're referring to the actual proxy, right?
Yes.
All right. So the proxy will only stay up as long as the actual page is open. What Dan Benet found during his test was he was actually able to get a surprising percentage of the people who browsed him to stay open for at least 12 hours. So it turns out that if you do pop under ads, those really annoying things that sit under your browser, people will just leave them there because they're designed to be left there. That's the whole idea. So if you have a really tiny pop under ad, yeah, you can actually make people not realize it's still there. The other thing to do is, a lot of the connections, if you're on a large enough ad network, you're just repeatedly finding yourself in the same network over and over and over again. And for most protocols, not all, but most, if your connection dies in the middle, you can resume it. Think about going to web pages, going to file servers, whatever it takes. If your session dies every few minutes, wait for the next person from that network to show up.
Okay, thank you.
No worries. All right, any other questions? Right there.
Regarding what you said about detection of provider hostility.
Yes.
What do you do when you have detected that your provider is hostile? I mean, you can change your provider, but maybe you may not have that option because it's the only provider that provides DSL service in your area. So
yeah,
what do you
it's
do?
called tunnel to a real internet service provider.
Okay.
So, a little bit of opinion. I pretty much think this battle is going to end very badly for the carriers. Sooner